Today I want to talk about bimetal protection systems and thermal overload relays. Hello friends, welcome to another video with Yakataro Shiley. Today I want to talk about bimetal protection systems and thermal overload relays. Why am I discussing these two together? In this video, I want to introduce them because their functions are very similar. Bimetal detects overloads thermally. What does that mean? When the electrical current significantly increases, it invariably generates a substantial amount of heat. This generated heat then causes the two distinct metals located inside the bimetal strip to gradually bend and ultimately separate from each other, thereby effectively breaking the electrical circuit. Now, considering all of this, what exactly does the term electrometer truly mean in this specific context? The bimetal is used to turn the electrometer on and off, but it is installed under the contactor. If excess current is about to reach the electrometer, it detects it, turns off the contactor, and as a result, our motor shuts down. Adjustable capability. What does adjustable capability mean? Now, if I want to show you this up close, this particular component is a bimetal. As you can clearly see, it prominently features an adjustment screw right here. What exactly is this important adjustment screw designed for? Here we have a current that we can set. When the current goes above this level and the temperature rises, it detects it and cuts off the circuit. Now, this button is the test button, and this other button allows us to switch it on and off automatically, or if we want, we can reset it manually. So that's about the circuit breaker. I explained to you that the bimetal itself doesn't directly cut the circuit or the electromotor. It sends a signal to the contactor turns off, and as a result, our device shuts down. Now, about the thermal switch. The thermal switch also detects overload, which causes heat, and as a result, it cuts off the circuit. It is installed directly in the circuit, not under the contactor or any other component, and it can independently detect heat and perform the switching on and off in an adjustable way. There are different models of thermal switches, rotary and push button type. If I'm not mistaken, here we have both the push button and the rotary types. This one is the rotary model, and this one is the push button type. The thermal switch offers more protection than the bimetal. If we want to use it in sensitive areas, we should definitely use a thermal switch. Also, thermal switches have different breaking capacities. They can detect both overload and short circuit, and they can perform the switching on and off. Now, one of the bimetals I explained to you, this is another bimetal from a different brand. Now, this is a thermal switch. Let me bring it closer so you can see. This is an ABB thermal switch. Here is where the phases are connected, and here is the adjustment screw which we can use to set it. This is also used to turn it on and off. So that's about the thermal switch. It also has another feature, which is an auxiliary contact that can be attached to it. For the bimetal, we don't have any special accessories. This auxiliary contact is also for the thermal switch, which can be attached from the front or the side. So we talked about bimetal and thermal switches, discussed their similarities, and also explained their differences. The differences are in the level of protection, the breaking capacity, and the manual on-off operation, which I showed you can be either push button or rotary. I gave you a complete explanation about everything. I hope you can make use of this information. Stay with us for the next videos.